right, we are going to do some scatter plots. Have you done correlation with scatter plots before? Yes. Okay. So hopefully some of this will be a little bit of review, and hopefully some of this will be a little bit of review. Some of it will be new. But first, okay, I want to talk about the different types of correlations. Okay, the first is a positive correlation. Okay, the second is a negative correlation, which you can see at the top of your page. Okay, a strong correlation can be positive and it can be negative. So you can have a strong positive. Okay, you can have a moderate positive. You can have a strong negative or a moderate negative. Okay, we're going to talk about those different types. And then we also have this other type, which is a weak association. Meaning the data that was graphed really is not related well to each other. Okay. So if we look at, in example number one, okay, I'm going to help you figure out what is a strong, weak, moderate, all that kind of stuff. So if you look at number one, it says, which plot seems to have a strong positive association? Okay, if it's strong, if it's positive, think about a line. Think about the slope of a line. Which one do you think looks like a positive correlation? Number one, right? It's going up from left to right, it's positive. And it's strong if the dots are really close together. So number one is definitely a strong positive correlation. Okay, which one do you think seems to be a strong negative? Number 5. Absolutely, number 5. Okay, and what do you think about a weak correlation?
3.
Yeah, 3 is really, really great. If you look at 4, it's still kind of negative, right? 6 is still mostly positive. So that's why 3 would definitely be the one with the weakest association, because you can't really tell where it's headed. Any questions on that? Okay. Let's go ahead and turn our music off, please. All right, we can use the correlation coefficient called an R value. Okay, for each data set. The R value tells us if it's a strong positive, weak positive, all that kind of stuff. Okay. Those numbers will be between -1 and 1. It'll always, always, always be between -1 and 1. Look at the bottom right corner of your notes, right down here. Okay, this is kind of the number line where you can kind of find stuff. So if we look at a data set that's close to 1, okay, which is over here, this is going to be our strong positives. Okay, strong positives. If I told you like positive 0.5, that would definitely be a moderate positive. Does that make sense? So strong is close to 1. Okay, if it's like 0.5, it's about in the middle. Okay, it's a moderate. If it's close to -1, that's a strong negative correlation. Strong negative is near -1. So you've noticed now, hopefully, that if it's 1 or -1, it's strong. And then as we get closer to 0, okay, it becomes weak. 0 is a weak association. Tracking with me so far? Yes or no? Yes. All right, example number 2. We're going to go ahead and put these numbers in where we think they fit. So, no correlation. Which number would be no correlation? 0. Okay, what about a strong negative? The strongest negative. Yep. Okay, that's the one that is closest to -1. So use those. Oh, sorry, we haven't used one yet. Okay, a moderate positive. 0.43. Good. Okay, our weak negative. Good. And then that leaves our strongest positive, which is 1. So again, the closer you get to 0, the weaker it is. Okay, example 3. Match the scatter plots below with the R value that most accurately describes the relationship. I want you to go ahead and do it, and then we'll see if we're similar. Okay? Go ahead and match the ones that you think fit, and then we'll see if we're similar. You can cross them up as you go. It makes it easier. What do you think? Do you agree?
Kind of tough. I had to point to a point for it. Yeah, I mean,
You guys need to switch?
yeah.
Yeah, you know, maybe that's a good idea. This is a really tough example to kind of see. You had it like that?
Yeah.
Yeah, I can see that. Because, okay, here's the thing. If we were to draw a line of best fit, do you remember line of best fit? We're going to talk about that tomorrow. But if you remember, this will probably be a little bit better there. This one, I think, tends to have more of a negative correlation. So if you can't decide if it's a positive or negative, it's definitely going to be weaker. So I think you guys had that one right. I think I had that one wrong. We good on that? Yeah. Okay. All right. Try. Oh well. Here we go. Try it. Go ahead and do this one on your own if you haven't already. Okay. See if you can figure out which one's the strongest correlation and explain why. Give me a good explanation as to why. All right, do you agree with me on B and C?
Yeah.
Yes.
Okay, what did you have for A?
3.
Okay. 3 for A. Yeah, that's a little bit better as well. So that 2 would go here. Sometimes it's tough when you get those last 2 in the middle. Okay, that's a good explanation for which one is the strongest and why it's the strongest. Yeah, go ahead.
The first one, I'm just like the most iced player, like it's the most obvious.
Good. So you should have said something about the dots being closer together. Okay? It's strong if those dots are closer together. What's next? Is it practice or is it?
Example.
Together, let's see.
The other one.
All right, let's go. We'll just get started again and I'll let you roll. All right, hours of exercise. Which axis is the hours of exercise? Go ahead and mark it. Okay, and then obviously weight loss will be the y-axis. Okay, now reminder, we are doing scatter plots. Okay, so this isn't going to be a straight line or anything. We're just going to be plotting points. It might be a little rough. So, like for example, if we plot 1.3 to 0.5, it's not going to be perfect, but just to your best. Okay. Is it going by 0.5? Is that what it says there? Okay. Hopefully it looks something like that when you get that plotted. Okay, do we have a positive correlation or a negative correlation? Definitely positive. If you look from left to right, if we look from left to right, it definitely is going upward, so it's positive. Okay, is there a point that seems unusual?
Yes.
Yeah, right? It's this guy right here. Okay, so that was our, what was that, 1.3, 0.5? Okay, we call this an outlier. Okay, it's called an outlier. Sometimes there's just data that really maybe just doesn't fit well with the other data. We're gonna do something a little bit later in the week that's kind of fun with like our shoe size and our height.
Yeah.
And so you'll kind of see like, do we have an outlier in here or do we not? Kind of go on. All right, estimate the R value. So we know that it's positive. Is it strong?
No.
The 4 points are, right? So you would say that these are strong, but this one kind of... So I would say, if we didn't have this one, what would you say the R value was?
About 0.7.
Without this, probably a 0.9. I think you nailed it. Okay, probably 0.9. With this, what do you think it drops down to?
0.7.
I would say it's 0.7. I would say it's 0.7. Okay, so R equals 0.7.
Thank you.
All right, I want you to go ahead. I think. Well, let's see. Yeah, try these OST questions on your own. I'm going to give answers here in a little bit. Just go to work on those on your own. Yeah, not for R value.
With no school anymore. A weekly basis, if I actually do go in, because sometimes I just don't go in because it does get really rough. It's 14. So I work 40 hours a week. At the end of the week, so after like taxes and stuff, wait, this is actually
There's just to figure out which one. I didn't know it was like.
You can work on it. I heard it too. Yeah. I heard the and Wendy's. But you can't work in the kitchen. they can always be not by law, it's like, but they don't care. I put but it's because like a lot of
That's wrong.
people look older, people
Using this one.
I agree.
$11 miles.
I say about $550.
I do more steaks.
No, I
really
say
good steaks. Steak, chicken, fish.
Rice soup.
I don't know where I said
Like
$550.
I want to sign up for this. I love.
I said $1.
Oh, wow, but I cook
I cook it. Because I promised her it. My great grandma actually promised her. She has the great. Oh my gosh, she wouldn't even give me this.
You gotta say eat.
Okay, group, we should be working on our practice problems. Only hurry. And once we're done with these, then you can have your talking time. But I need you to work on those 3 problems, and then we'll be done. Okay?
That doesn't make sense though. It's -0.9 is close to 1. Because -1 is
Yeah,
a...
but these are that positive, that's positive, that's negative. Oh, you're so
Cooking it is so rough, but it's so good. Even start out on the main thing, you start out the same. My church
isn't a weak correlation.
it's weird.
But she had a cure.
Yeah. Yeah.
But it was good.
How is that wrong? Hi.
Every time I go somewhere, I want to think they're sweet, and not sweet, they're sweet children.
Mature.
They claim trips.
I wonder if it's safe.
I don't know why it's just
You're all set.
I'm weak. Grilling salmon is really easy.
Okay, are we ready?
Yes.
Yes? All right. So example number 5. The estimated rent. Let's focus. I need 5 minutes, group. Okay. Estimated rent for the house in the center of the city. What do you think? Well, it's $140. House. Okay. Find up here, please. Okay, distance from the center of the city. So if you want the center of the city, you want to get close to 0, right? So up here, it looks like it would be around $1,400, right? If you went a little under that, that's fine, because I know we're doing a line of fence there. So I would say anywhere from about $1,300 to $1,400 would be a good rent. Okay, the estimated minimum rent for a house far from the city. What do you think? Okay, somewhere between here, right? Somewhere between 5 and 600 would be totally fine. Okay, the estimated change in rent for each additional mile from the city. This would be kind of like a slope. Go ahead. About $200. I don't think that's too bad. Yeah, I think that, yeah. About $200. Okay.
Oh, yeah, you guys said that.
All right, the estimated change in distance from the center of the city for each dollar change in rent. So change in distance now. Change in distance, what do you think?
2 miles. Okay.
So, you know, it would be hard to say like per dollar, but okay, about every $100. What do you think?
2 miles.
2 miles?
Yeah, 1.5.
Well, if we said that each additional mile is $200,
Mile.
I would say somewhere between a half to 1 mile for each $100. Okay, per $100. Okay, now figure that out per dollar. You would never have to do that. Okay. All right. You're gonna sketch your line of best fit. I know we didn't talk about this today. We're gonna talk about it tomorrow. But your line of best fit would be somewhere like there. Okay. Doesn't need to be perfect, but something like that. Okay. You want to have the same amount of dots on one side that you do on the other side. Because it's
That's what I thought.
oh.
Yeah, that's what I thought.
What?
Oh, you just got playing plus.
I agree.
I was hurt.
That's really cool.
Why are you doubting me? I swear.
Okay, which one did you hate it? Yeah. Yeah. Well, that's okay. We will evaluate it. Okay. Really quick. Using this line, predict the cost of rent of a house 11 miles from the center of the city. What do you think? What do you think it would be?
400.
What I told you.
About 400. About 400. Hey, keep in mind, nothing is perfect when it comes to a scatter plot. Okay? Alright, example number 6. Which one would you choose? Hey, negative 0.9 is a very strong negative. Very strong negative. Okay, last one. The weakest correlation would be anything close to 0, which is these two right here. Okay? Those are the two that are closest to 0.
Yeah, but they made it. And it's close.
Yeah, I didn't
Turn my plate back. Or I could work out a further.
But story says
if somebody's not no, those are the lines to the graph.
I think I'm so good.